Hello, beta. Hello, 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 hello. Welcome back to my YouTube channel. Hello, beta. Good vibes. Hello. Asana, beta. Hello. Today we have to do electrical energy and power. No, beta. Basically, I guess in last class we had completed Ohm's law, right? And the temperature coefficient. Hello, beta. Hello, 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 hello. The alpha one. R final equals to R initial 1 plus alpha delta T, and R the temperature difference should be very less and alpha needs to be constant, and the temperature should be in degrees Celsius only, right? So this thing we discussed in the last class. We check. Temperature dependency of resistivity whole we had done now. Yes, we had completed the temperature part, right? So now in this class, we will be starting now the resistance part. Okay, resistance in a series, in parallel, in all these types of numericals we will be doing here, and how the voltage distribution will takes place in series and in parallel. And second one is how the current division will takes place. Okay, so these things we will be discussing in today's class. If you are prepared, look, we have a lot of things now that we want to clear, right? Power and all these things, no, it comes, I guess, today we will complete a resistance part, I guess. Then we are having cell, okay, internal resistance, all these things, EMF, voltage, right? These things we need to discuss. Then we have to complete the power part, the bulb, no, brightness of bulbs things. Am I lagging? Am I lagging? Hmm? That's great then. I guess we need to start now, no? So let's start. Okay, let's start now. Yeah, now I guess everything is good, no? Sometimes, due to my network issue, sometimes it happens, right? It usually happens after 12 o'clock, but I don't know. Okay, so let's start. So we are dealing with resistance part. So today we are having lecture number 4. Lecture number 4. So we are dealing with a resistance part, okay? Or I will write combination of resistances. Combination part. Combination of resistors. Combination of resistors. I guess sometimes it's stuck, no? Let me check. Let me check. Okay, but I guess this one is my second class or third class. No, this one is a fourth class, huh? Okay, now, so first thing is that we will be starting here now. First thing is series combination. Series combination. I guess you people are very familiar with the series combination from your 10th class. Okay, the whole motive is to get the equivalent resistance. Okay, suppose we are having one resistor, second resistor, third resistor, and we are connecting these three resistors in a series sense. Series simply indicates that, look here, this is my first resistor, second resistor. This one is starting point. Now it is starting point of first one. This is end point of second one. Starting point of second one, end point of second one. If we are connecting the resistors in a sense that after first resistor, if second one is getting connected, okay, look, whenever we are connecting the second is starting part with first is ending part, this type of combination is known as series combination. This type is known as series combination. Now look here, this particular thing is known as battery. Okay, battery or a cell. So you will get confused. Now I will just do one thing. I will just write it is a V voltage battery. Okay, this long slide mean is positive, the shorter mean is negative. Look here, first one resistor is having value R1, second is R2, third one is R3. So what happens across these three resistors, potential difference takes place, potential drop. V1 is across the first one, V2 across the third one, sorry, second one, and V3 is across the third one. Okay. And if we are talking about current, now look, I current will leave your battery and I will get into the battery. If 2 ampere is leaving your battery, 2 ampere will get into the battery. If 10 ampere is leaving the battery, 10 ampere will get into the battery. This is a very important parameter, right? Amount of leaving current and amount of entering current must be same. This thing, okay? Look now, look here. We are only having one way. Now look, this current will flow up to this point. Then this will flow up to this point I current. Here it will leave this one I, this one I, this one I, and this one I. It simply indicates that here the same current will flow through all the resistors. Simply indicates the current will flow through all the resistors. Or you can just simply state that current will behave as a car, okay, as a multiple cars, and the resistors known as speed breakers. Okay, I guess the working of speed breakers is only to reduce the speed of your car, but the number of car is constant, no? In the same way, here the resistors, no, it reduces some sort of effect of current, but current is same. But current is same. If we are applying the Ohm's law here, so I can write V equals to I into R. This one is for your battery. Okay, now for this one, R1, now for R1 I will write V1 equals to IR1. Current is same. V2 equals to IR2. Okay, sir. And V3 equals to IR3. Done. So what I can write here? Now I can write here, sir, net V, the outer V, it will be equals to V1 plus V2 plus V3. What is V? V is IR. I into R series. V1 is IR1. V2 is IR2. And V3 is IR3. Now I will cut the current. Look, same current, no? So therefore, in series combination, it will be equals to R1 plus R2 plus R3 up to so on. If you're having series combination, so you need to add the resistances in this particular manner, R1 plus R2 plus R3. If you are having n number, then R1, R2, R3, R4, R5 up to the n. Super easy, no? Super easy. Now look here. What I can write now? So in series combination, we know now one thing. Okay. So in series combination, so resistance in series is equals to R1, R2, R3 up to so on, or up to Rn. If we are having n number of resistors, right? N number of resistors. Done? What if I will just ask you one simple question, that is, if the value R1 equals to R2 equals to R3 and so on up to Rn, if the value of all the resistances is equals to R, so therefore my net resistance, it will be equals to n times R. Just remember this particular part, okay? This one. If we are having n number of resistors with equivalent resistances, so their net resistance will be n times R. So their net resistance will be n times R. Sports law, sir. I'm a graphic designer, sir. I'm designer. Some are interested. No, I don't need these things. Right? I don't need these things, right? I'm not a YouTuber, right? I'm simply a teacher. Thank you very much for your this thing. Thank you. I guess something happens with your network now always. Every time I class this happens now with a network issue. Every time. Look now. So in series combination, so you can write in series combination. Most important thing, in series combination. In series combination, current is same. Current is same, right? Current is same. So therefore, what I need to write now, look better. We know that V is equals to IR. Current is same, that means V is proportional to the R. Okay, this thing is important. This one is important. V is proportional to the R. Sir, how this particular point is important? Look now. Look now. So I will show you now one technique by which you will divide your voltage, right? So the thing known is voltage division technique. Voltage division technique. Voltage division technique. So let us suppose we are having these two resistors. Potential is V. First one value is R1, second one is R2. Done. If you want to find out this V1 and V2, if you want to find V1 and V2, how you need to find it now? Look, V1 means the potential differential drop across R1. V2 means R2. So what is the relation between V and R? Sir, the relation is directly proportional. Here you can see now, it is directly proportional. So how you need to write? Sir, I will write V1. Potential across R1 equals to R1 divided by R1 plus R2 whole multiplied by V. Same, what is V2? Sir, V2 means across R2. So I will write R2 divided by R1 plus R2 whole multiplied by V. These are two formulas. You need to memorize these things. Done? Look now, we will do a numerical. Now, based on the same concept, we will do a numerical. Look now. Look now. Okay. So let's say this one is 10 volt. First one is 2 ohm. Second one is 3 ohm. R1 by R1. But how R1 by R1 equals to R2? Okay. So how we will get V1 and V2? Look, by the formula, na. So I will write V1 equals to R1 is 2 divided by R1 is 2, R2 is 3. And V is 10, right? So look, 2 plus 2 multiplied by 10 is 20 divided by 5. I guess this one is 4 volt. If the total is 10, this one is 4, this one is 4 volt. So this one will be 6 volt. Simple. Done. If first one is 4, second one would be 6. So I will use the formula also, not no issue. Sir, it would be R2. R2 is how much? 3 divided by 2 plus 3 multiplied by 10. So I will get 30 by 5. 5 1 is 5 6. 6 volt. This is how we need to apply the formula. Ansh Mishra, no. But you are saying something different, na? I guess you need to just see your answer firstly, okay? Okay, now this was series combination, and in series combination current is same, so we don't need to find the current now. We have to find the voltage. So now we got the way how to find the voltage across the resistors. Now we are dealing with second case. Case number second means parallel case. Okay, I guess in parallel combination you know that voltage remains same. Okay, V remains same, but I different. I will be different. Look now. So let us suppose we are having one resistor, 2 and 3. We need to look, it is starting point, end point. Let us suppose now starting, end, starting, end. If we will connect to all the starting point together and we will connect to all these ending point together, so this particular combination is known as parallel combination. Look better. How? Look. R1, second one, R2, third one, R3. Let us connect these things now to a common point. To a common point. Okay. Now connect an external battery. Look now, with V voltage, okay, current I will go out from the battery and current I will go inside the battery. Now at this particular path, now look, it will divide current in three paths: I1, I2, I3. I1 will leave this one I1, this one is I2, this one is I3. All these get add up and it will become I. So I will leave this particular point, this I. So you will see here now the I is equals to I1 plus I2 plus I3. Okay, V remains same. V remains same. So what I will write here now, I will write here, sir, we know that V is equals to I into R. I can write like this now. Okay, okay. Look, I guess potential is same. Potential is same. So potential across R1, potential across R2, potential across R3 remains same. So for this one, what I will write? Sir, is it V is equals to I1 R1? Can I write like this? This V, is it I2 R2? This one, I3 R3. Done? Okay. So what I will write here now? Sir, look, I equals to I1 plus I2 plus I3. I can write like this also, no? What is I? Sir, I is V by R. So it is V by R parallel equals to V by R1 plus V by R2 plus V by R3. I will take V common and it gets cancelled. So 1 by Rp equals to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Done? Yeah, in parallel, potential remains same. In parallel, potential remains same. Okay? Look, potential basically depends the starting and the ending point of your resistor. Potential depends on the starting and the end point of the resistor. Look here, in this case, now in series case, look, the starting point and end point, okay, different for both these three cases. Now we have starting and end point both different, right? So potential will be different. But if you're talking about the parallel case, look here, starting, end, starting, end, starting, end. Okay, starting and the end point is same for all of the three one, no? That's why potential remains same. So based on this particular equation, we got to know that how to find the equivalent resistance. Equivalent means the net one. Equivalent resistance means the net resistance. Okay, this is how we will find the equivalent resistances. Done now? If we are having one more point here now, if we are having n resistors, the value equals to R. So therefore, my equivalent resistance R net will be equals to R by N. It will be R by N. The equivalent resistance of your parallel resistors, if all the resistances have the same value R, so their equivalent will be R by N. But in series combination, it will be N times R. It will be N times R. Easy or tough? Easy or tough, beta? Huh? Any confusion? You can just let me know there, no? If you don't know now how this thing came now, look now. So I will write 1 by R net or R equivalent equals to 1 by R plus 1 by R plus 1 by R up to so on, right? So what I will write here, sir, it will be N by R equals to 1 by R equivalent. So I need to just reciprocal it now. This particular point, right? It will become R equivalent by 1 equals to R by N. It is proof, no? Simple. Okay. Now, in the previous case, we know that potential gets divided. So we came across a formula by which we will find the potential. But here in this particular case, now, what divides? I guess current gets divided. So now in this particular case, we are going to find out how to get my equation by which I will get my current. Okay. So what I will write here, current division technique. I will write here current division technique. Current division technique. Okay. We know one thing now, sir. What? By Ohm's law, V equals to IR. In this parallel case, V remain the same. So can I write here, sir, resistance is inversely proportional to the current? Can I write this one? Can I write here that resistance is inversely proportional to the current? Or current is inversely proportional to the resistance? Now I can write one this thing also, right? What, sir? I is inversely proportional to my resistance also. I can write like this one also. No issue. Okay. Now how we can use it? Now how? Look, if we are having like these resistors, look now. Okay, look here. If I current is flowing, I current, it will get at I, no? Here, R1 resistance, I1 current. R2 resistance, I2 current. It's flowing, no? Like this. Okay. Okay. I guess between this resistance now, between this resistance and this current, it is inversely proportional. I guess these two things are inversely proportional. Yes, sir. These are inversely proportional. Then I guess I can write I1 current. I1 current is equals to inversely proportional. I don't need to write R1. I will write now R2. R2 divided by R1 plus R2 whole multiplied by 1. Sorry, I. Why here we are having R2? Because, sir, the relation is inversely proportional. Now, how to get I2? Sir, same I2 is I1 divided by, sorry, R1, no? R1. It is R1 divided by R1 plus R2 whole multiplied by the I. So previously, V1 is R1 divided by R1 plus R2 into V. And V2 is R2 divided by R1 plus R2 into V. But in I case, it is I1 equals to R2 divided by R1 plus R2 into I. And I2 is R1 divided by R1 plus R2 into I. Now, how do you use this one now? Look, how do you use this one now? See, easy, right? Now, how to use this one? Look now. if we are having a circuit like this, if we are having a circuit like this, current is, let's suppose, 21 ampere. 21 ampere is getting into it. So 21 ampere will leave, no? 21 ampere will leave. If this one is 4 ohm and this one is 3 ohm, so current I1 will flow through this one and current I2 will flow this one. So how to find I1 and I2? Sir, for I1, I guess I know the relation. It is R2 divided by R1 plus R2 multiplied with I. So what is R2? Sir, R2 is 3 divided by, it is 4 plus 3 and I is how much? 21. Okay, I will write 3 divided by 4 plus 3 is 7 into 21. 7 1 7, 7 3 21, 3 3 is 9 ampere. So through this one, it is 9 ampere. If total is 21 ampere, I1 is 9 ampere. So how much is I2 now? How much is I2 now? Huh? What will be the value of I2? Sir, it will be 21 minus 9. Done, no? So my value would be 12 ampere. I can get it by the formula also. No? I2 is R1 divided by R1 plus R2 multiplied by I. R1 is 4 divided by 4 plus 3 multiplied with 21. So it is 4 divided by 7 into 21. 7 1 is 7, 7 3 21, 4 3 are 12. It is 12 ampere. Done. So you know now how to put your voltage division techniques and current division techniques. You know now, no? Huh? Yeah, perfect, perfect. 12 is good. Yeah, 12 is correct. One more time. I got encountered with a lag. Okay. Now, what we are going to do now? You need to fix this thing to your mind. How to find current and voltage. Okay. Now, let us do some numericals based on your equivalent resistance. Look now, first numerical. First numerical. If we are having something like this, now look. Okay. So A, B, C. 6 ohm, 1 ohm, 2 ohm. Find equivalent resistance across A and B. Okay. When you are getting these numericals, now between A and B, that means you have to think about that we are having a battery and battery is connected between these 2 points, A and B. Between A and B. Now, if you are seeing this particular figure, now look, A and B. I guess if let's suppose current I is flowing. Look now how you need to tackle with these problems. Look now, if let's suppose current I is flowing, okay, and I will get into your battery. We know it. Now this particular point I is there. Now here, sir, my I1 would be there. Here, sir, I2 is there, right? So what will happen now? This I1 will flow and cross this one resistor I1. And it will go same here I1. It will go same here I1, right? Here I2, I2. Then here I guess based on these things, now we know that in series combination, current will be same. Look here, sir, I1 will flow across 1 and same I1 will flow across 2. So by this particular thing, now you come to know that 1 ohm and 2 ohm, these two resistors are connected in series. Okay, so these two things are connected in series. And how to find RS? Sir, RS is equals to R1 plus R2. R series. What is R1? R1 is 1 ohm and R2 is 2 ohm, right? I guess it is 3 ohm. Now I will write this one as a look now, same now, look. It is 6 ohm. Okay, here this one is 3 ohm now, and my battery is connected here. This one is a battery, no? Look, I1 is there, I2 is here, right? If we're having two resistors and with different current, I guess these two resistors are connected in parallel. These are connected in parallel. So how to get the answer of parallel? Sir, I know that 1 by R parallel is equals to 1 divided by R1 plus 1 divided by R2. I will do a simple mathematical calculation. Sir, it came out to be R2 plus R1 divided by R1 R2. So a resistance in parallel came out to be, sir, R1 R2 divided by R1 plus R2. Sir, what is R1? R1 is, let us suppose 3. R2 is 6 divided by 3 plus 6. It is 18 divided by 9. 9 1 is 9, 9 2 is 18. So the equivalent resistance will be equals to 2 ohm. So my answer came out to be 2 ohm. Easy, tough, or super easy? With this particular question, you come to know that how to put the formulas, how to figure out how to identify the series combination and parallel combination. Super easy, no? Super easy. Okay, one more numerical. One more numerical. Super easy. One more numerical. Numerical number second. Find R equivalent between A and B. Between A and B. Okay. Look, first 10 to 15 numericals will take time, na? Why, sir? Because to identify series or parallel combination. Look here, if let us suppose we need to find between A and B. What is short trick? Sir, I will just assume that there is a battery. Look now here. I will be there. So here current will divide. Two ways, na? Sir, I1 current, I2 current. Look, I1 here, I1. Same I1. Same I1. Same I1. Same I1. Here is I2. Same current flowing across your resistor, same current, same current, same current. It simply indicates these three, this one, this one, this one belongs to series combination. Series combination. What? Series combination. And for series combination, R equivalent equals to R1 plus R2 plus R3. R1 is R, R2 is R, R3 is R, equals to 3 times R. I don't know now what happens with my network every day, every day. Okay, my network is good, up to 9 or 10 p.m. My network is super good, right? But after my 10 o'clock and these things, it drastically gets changed. Nah? Its polarity changes then from super good to super disastrous. And I don't know the reason behind it. I don't have any clue about it. And due to which my class suffers, nah, like lot. Hmm? Also, your concentration gets. Hmm? So I am using some sort of Airtel fiber, na, and it is extreme disastrous. Now it gets good now. I don't know how long it will be the good. Okay, I guess it gets now consistently good. Okay, look now. So, okay, one second. I didn't change my preference. One second, one second. Look now. So now I need to rearrange the whole thing now. How, sir? Look, I will just make it like this now. Look, this one is 3R, this one is R. Okay. So now these two are connected in parallel combination. Which one? Parallel combination. So for parallel combination, R equivalent is R1 multiplied by R2 whole divided by R1 plus R2. Okay. So what is R1? It is 3R multiplied with by R whole. It's 3 by 4R. I guess I'm just on a good setting now. Hmm. It is 3 by 4R. With every numerical, na, the level of hardness will get increased. Na? With every numerical, it gets hard. Okay. Now you will see the solution of this one. How we got 3 by 4R. So now your responsibility is to identify the series combination and parallel combination. For series combination, use the equation series one. For parallel combination, use the parallel one, right? And at the end, you will get your answer. One more numerical with some with combination of both, na, series and parallel. Free. It gets rectified, na. Do one thing, na. My voice is good, na. My face gets stuck, na. Don't think too much about my face. Just go with the voice only. Can't do anything with it now, no? I can't do anything with it. Nothing I will do with network now. Either I need to change the timing of my class in the morning shift. But I know that you will be in the class school, no? Maximum students will be in the school if I will shift my class in the morning, 10 o'clock or 11. Look, I will call the service provider, right?